area between two curves. So before we were looking at the area under one particular curve, between that and say the x-axis. Now we're looking at the area between two different curves. So we have our curves y is equal to f of x and y is equal to g of x. And we're looking at that between our points x is equal to a and x is equal to b. We have a formula for this where we integrate our functions here. So we're going to do our f of x minus our g of x between our points here a and b. We can also look at the area between the curve and the y-axis. So before we were looking here at these points down here on the x-axis and the related area. Now we're actually looking here at these 2 points on our y-axis and this area in here. So here we're actually going to find our integral with respect to the y-axis. We'll express our curve as so x is equal to h of y, and we're going to find our areas between y is c and y is equal to d. So here our area between c and d on our y-axis is our h of y with respect to y there. And we're using horizontal strips with width dy to do this. Okay, so now if we look, we want to find the area between y is equal to 2x squared. So if we were to plot that here, this is our y is equal to 2x squared. And here we'll put in green, y is equal to, we can write this one out, y is equal to 3x minus x squared here. And this is here. So we can go through the process and find how to plot these, but at the moment we're interested in finding these areas. So if we go over this one in green, just to make it a bit clearer. If we looked at the area under this between our points, or we look at this area under here, we're looking at this part here. If we're looking at here is our blue line here, and we can find our area under here as well. And this part that's coloured in yellow, we'll circle it in red. But what we're doing, it's this area under this green bit minus this part that's here in red, and that will give us this part in here in the yellow. So what we need to do is go through and we're going to find our area under here, our green curve, y is equal to 3x minus x squared, and subtract away the area under our blue curve here, y is equal to 2x squared. Our first step is we need to find our points of intersection. So our points of intersection is where they meet. So we're going to say, well, we have y is equal to 2x squared and y is equal to 3x minus x squared. These will meet when we make our two y's equal. So 2x squared is equal to 3x minus x squared. So 3x squared minus 3x is equal to 0. We can take 3x out of this. We're getting x minus 1 is equal to 0. So here we have either x is equal to 0 or x is equal to 1 are our 2 points where this is true. So here x is 0 and here x is 1. There are our 2 points there. So we're going to integrate between those 2 points. So our area, we integrate between 1 and 0. And here we're going to work out what's going to be our f of x. So it's going to be this one here. So we're going to have 3x minus x squared minus our other one here, 2x squared. So here we integrate, or we'll go through this. So here we simplify 3x. We've got minus x squared minus 2x squared minus 3x squared here. So now we can go through and integrate here. So here 3x becomes 3x squared on 2. And here we have 3x squared becomes cubed on 3. Between 1 and 0 here. So we substitute these in for our 1 values. 3 times 1 squared on 2 minus 1 cubed minus 3 times 0 squared is 0 on 2 minus 0 here. So we end up here 3 on 2 minus 1 minus 0. So here 3 on 2 minus 1 will give us a half, and we write in here a half square units. So moving on to our next example here. We want to find the area between these two regions here. We have y is equal to x to the power of a third and x plus y is equal to 2. So if we look at these graphs, here we have here y is equal to x to the power of a third, and here is our x plus y equals 2. So when we look at this, it's quite difficult. If we wanted to try and go through this, if we looked here, our area under our y equals x to the third is there, and our area here under our x plus y is equal to 2 is here, and it's not a nice subtraction really to take that one away from that one. But if we look at it on our actual y-axis here, so if we look at our y-axis, here we have our x plus y is equal to 2, and here we have our area here above that. So what we're going to do is move this around to be in respect to our y-axis. So here, if y is equal to x to the power of a third, here we can cube both sides, and so x is equal to y to the power of 3. And we have x plus y is equal to 2. Here, x is equal to 2 minus y. So if we set these as equal, we say, well, y cubed is equal to 2 minus y, and we can look at this and we'll say, well, 1 works, doesn't it? 1 cubed is 2 minus 1 is equal to 1. So we're going to say, well, this point where they meet is the point 1 there. And we substitute that into our original equation. 1 plus 1 is equal to 2, so our y value is also, x value is also y. So now we can go through and we can actually differentiate this. So here we're differentiating between 1 and 0 here on our y-axis. And we're going to substitute in, so we've got 2 minus y cubed here. So we differentiate these, integrate these, we're going to get 2y minus y squared on 2 minus y to the power of 4 on 4. Between 1 and 0. So we'll move this down to here. We substitute our points in. We've got 2 times 1 minus 1 squared on 2 minus 1 to the power of 4 on 4 minus 2 times y is 0. Here 0 on 2 minus 0 on 4. So here we've got 2 minus a half minus a quarter minus 0. So here 2 minus a half minus a quarter will give us 1 and a quarter there. And remember to write square units. So moving on to some of our exercise here. So exercise 10.1a. We want to determine the area enclosed by the curve y is equal to x squared. The x-axis, the line x is equal to 1 and the line is x equal to 3. So we're going to start by drawing our curve. Y is equal to x squared is like this. Y is equal to x squared. We know we cut through, that's our point 0, 0, and here is our point 1, 1. And we want our point here 3. So we're looking at this area over here between x is 1 and x is 3. And our x-axis and this line here. So what we're going to do, we're going to integrate between 3 and 1. These are our 2 points here. Our equation here is x squared here. So we integrate this, we're going to end up with x cubed on 3 between 3 and 1. So here this becomes 3 cubed on 3 minus 1 cubed on 3. So it becomes 27 on 3 minus 1 on 3. Here becomes 8 2/3 units squared, or square units. Okay, so now moving on to 10.2a. Okay, question 2. So here we're going to sketch our curve with this equation here, y is equal to 6x minus x squared minus 8. So here our first step, we're going to say, well, here our y-intercept here is at y is equal to minus 8. So here we can simplify, well, here y is equal to 6x minus x squared minus 8. We can simplify this to 4 minus x minus 2. So here our x-intercept will be here at x is equal to 4 and x is equal to 2. So now we can differentiate here. We're going to say, well, here dy on dx here will be 6 minus 2x, and our 8 will disappear. So here we're going to set this equal to 0. 6 minus 2x is equal to 0. 2x equals 6. X is equal to 6 on 2 is equal to 3. And when x is equal to 3, we can substitute into our equation here and we'll get y is equal to 1. Now we look at our second derivative here. So our 6 disappears and we're just going to end up with minus 2. So this is negative, so this will be a maximum. So we're saying maximum at the point here, 3, 1. So now we're going to start to draw our curve here. We know we cut through our y-axis here, or cut through our x-axis here at 2 and at 4. Here at x is equal to 3, y is equal to 1, so at 3 and 1 here we have a max. And we cut through our y-intercept down here at minus 8. So our curve will go like this and on. So now we're wanting to find our area enclosed by the curve and the x-axis. So we're going to find this area in here. And what we want to find is our area between x is equal to 4 and x is equal to 2. For our equation, 6x minus x squared minus 8. So now when we integrate, we're going to have 6x squared on 2 minus x cubed on 3 minus 8x there, between our points 4 and 2. So this will simplify here to 3x squared. So now we can substitute our points in. So for 4, we're going to have 3 times 4 squared minus 4 cubed on 3 minus 8 times 4 minus 3 times 2 squared minus 2 cubed on 3 minus 8 times 2. So here we're going to end up with minus 5 and a third minus 6 and 2/3. So negative becomes a positive, so we're going to end up with 1 and 1/3 square units. There. So now moving on to question 3 here. We want to determine the area enclosed by a curve y is equal to x outside of x minus 2x, 3 minus 2x, and the straight line y is equal to x. So we're going to, first of all, well, here y is equal to x, 3 minus 2x here. This will become 3x minus 2x squared. So we can say, well, here our y-intercept is at, here y is equal to 0. So now our x-intercept, so we're going to say, well, 3x minus 2x squared is equal to 0, or we put it back here, it's going to be here x is equal to 0, and here also equal to 3 on 2, or 1.5. So there are our two intercepts there. So now we can differentiate here. Well, dy on dx here becomes 3 minus 4x. We set this equal to 0. 3 minus 4x is equal to 0. 4x is equal to 3. X is equal to 3/4 there. And we can substitute in our y. And our y should be 1 1/8 there. So we take our second derivative. here, and we end up with just minus 4. So this will be a maximum at this point. So now we can start thinking about our line here. We say 1, 2, minus 1, 1, 2, minus 1, minus 2. Okay, so just put these points in here. X is 0, Y is 0 is 1 point where we cut through, and here at 1.5. We have a maximum here at X is equal to 3/4 and Y is 1 1/8, so about here. And so our curve goes like this. Now we can look here, our other line is Y is equal to X. And Y is equal to X will go through here, there's our point 1, 1, and keep on going. So first of all, when we want to try and work out where we're actually going to cut through, we need to set these to be the same. So Y is equal to X, so X is equal to X, or we'll write the long way out here, is equal to 3x minus 2x squared, or we get 2x squared minus 3x plus x equals 0. 2x squared minus 2x equals 0. We take 2x out the front. Here x minus 1 equals 0. So here when x is equal to 0, we're going to have these points meet. And also when x is equal to 1. So our point here at 1, 1, they also meet. So we want to find our area enclosed here and the straight line. So we're finding this area between them both here. So what we're going to do here, we need to differentiate between integrate between 1 and 0, and our formula we're going to put here our 3x minus 2x squared from this one minus our x here. So this will become between 1 and 0, 2x minus 2x squared there. So here this will become 2x squared on 2, cancel, cancel, minus 2x cubed on 3 between 1 and 0. So here we substitute our values in. It's going to be 1 squared minus 2 times 1 cubed on 3 minus 0 squared minus 0 for the rest here. So here that was 2 times 1, so it's 1 minus 2/3 is going to give us 1/3 and 0. So here we're going to have 1/3 units squared between these two lines here. So we'll move on now to number 4. So here we want to work out, determine the area of the finite region between the curves y is equal to x squared and y is equal to the square root of x. So what we need to do is same sort of thing as for question 3, but this time we're just going to draw them up rather than work out all of our points through here. Y is equal to x squared is a nice easy one like this. We know we go through our points 1, 1, and here y is equal to x cubed, we go here, square root of x, we go here. So we can set these equal to the same thing. So here x squared equals the square root of x. So here we can go through and we're saying, well, for these to be equal, they can be equal at 0 and at 1. So we can go through here, we can square both sides and work our way through, but we end up with 0 and 1. We want to find this area between them here. So we're going to here integrate between 1 and 0, and we're going to put in our equations. So here our higher one, square root of x minus x squared here. And we can also write this 1, 0, x to the power of a half minus x squared here. So we integrate these, we're going to get here x to the power of 1.5 divided by 3 on 2 minus x cubed on 3 between 1 and 0 So this becomes x to the power of 1.5. So here our 2 moves up, 2x to the 1.5 divided by 3, minus x cubed on 3 between 1 and 0. We substitute our values in. 2 times 1 to the power of 1.5, or 3 on 2, divided by 3, minus 1 cubed on 3, minus. Here becomes 0 on 3 minus 0 on 3. So we substitute these in, we're going to get here 2/3 minus 1/3 minus the 0, and it will be equal to 1/3 here. Units squared or square units.